Hello and welcome to my channel. This video is going to be an iSWA tutorial, just basically showing you how to manipulate the timestamps or the sections of the videos you want to look at. So say you're watching a video somewhere and you want to go to iSWA and look at this yourself. Well, you just go to the signet, hit the drop down menu. This is up to date. You just choose your date and time. Well, here's your date and year. You can go all the way back to 2015 is pretty good with everything there. You get farther on back, it's going to be spottier and spottier what's available for you to look at. But it is there. There's older archives. Um, as far as the date and as far as the time, the easiest way to deal with it, instead of going through and clicking on these little arrows here, especially if you want to go down because it shifts on you, just see how it shifts back and forth on you, really annoying. Just clear it out and just put in the time. Usually you just got to put even just 2006, do 2-digit, I think. Yeah, always 2 digits. So you want to go 5 a.m. UTC 20, and you just click on it. That's how you get your time in the easiest way. Now when you first load this, the number of frames is gonna show, I think it's 50. It's probably even less, maybe even 10. Actually it is 10 because I remember just adding a 0. So you want to go from the default 10 frames, which is maybe an hour or two. Just throw another 0 on here and you'll get a 5-hour frame, a 5-hour video clip. Okay, 3 frames per second I don't deal with, and apply. And then if there is something there, it will show it. So here's 2000, December 8th, 2016. It's just what we put in, and shows up here at the top as well, your timestamp and date. Now, say you are brand new to this. You're going to see it look like this. Okay, when you first open these signets. And if you want to see, let's just refresh. And okay, so you're going to get the most current image like we have right now. If you want the videos, you just click on the little play button here, and then it's going to give you your default. Well, it would okay, now say now it would give you your default settings. So I would automatically add a 0, not change anything, and hit apply. And see, according to the timestamp up here, we'll say 12:36. I'll just throw it all the way over to the right side, and now we're at basically a 6-hour window of the magnetic tool, field lines. This is the best tool right now, literally, because magnetics is what's important. WPC has some similar models, but they don't have magnetics. They don't interest me, because these are the better tools, even though they're older, because everything else is here and you've got the magnetics too. Okay, now these are some little tricks of the trade I learned. Not really that, but tricks to manipulate this easily, real quickly, instead of coming in and changing this around and fussing with the time. If you say, like I said, it's right now, it's up to date. Say you want to go back 5 hours real quick. So no, I'm sorry, 6, because we have a 6-hour window here, and you want to drop back 6 hours before real easily. You just move this forward. I'm sorry, you have it at the beginning. Move over here, click apply. So 12:36 was the beginning. Now it's 6:48 was the beginning. We just dropped back 6 hours by moving the slider over and clicking apply under here. That's a little trick that makes it easy. So I want to go 6 more hours. Say I'm looking for something, But I know I'm 18 hours beyond it now. Instead of fussing with that, I could just do this, and now I should get the 6 hours before, so we should be at, yep, right at midnight. See, that's a neat little trick I learned. And then if you want to go back to up to date, you just refresh it here on this icon here, the green arrows. Okay, since we're going over the model, I'll just go over the rest of it real quick. This is the scale. It's RE, Earth radii. That is three. If you look it up, it'll be 3,963 miles. So this is Earth. Light side. The sun is over here, shining its light into Earth this way. This is the Earth in this model. Sun side, dark side, or night side. This black area is an area that is ignored by the satellites, and they are right here. Let me just stop this. Here is what they label as GOES 14 and GOES 13. These satellites are in geosync orbit inside the bow shock, not out at the L1 Lagrange point. There are other satellites there. Discover, ACE, that's where they are. Well, GOES and every satellite in geosync orbit is inside the bow shock here. Now, obviously, they have advanced to be more on like GOES 15 and 16 now. 17's out there, but it may not be using any resources for iSWA or SWPC. I don't know. So the moon is shown on here, but it's never visible on the model. Never. It does orbit here at 60. So this is a side-on view. North, south, equator. The moon would be here orbiting around. Okay? IMF blue. A great example is this. IMF meaning interplanetary magnetic field lines. They are not connected to Earth in any way. This is a prime example of a magnetic signature that is not connected to Earth. This is Earth magnetic field. This is the interloper's magnetic field. This is a planet or a moon. I do think it's smaller than Earth because its field is encapsulated inside Earth's magnetic field in this model. Now, you want to learn how far this model looks back behind Earth. You just take 3,963 times 90, and there you go from Earth on back. This Z-cut is also Earth radii. So I went over IMF. Polar cap is Earth's magnetic field lines, which are shaped by the solar wind. That's why they're shaped the way they are. So, and they're also susceptible to other fields, which we are seeing here exactly. We have closed field lines in red. This is pretty much a normal closed field line situation, but beyond this, you see any more, it starts coming out or just going all the way out the back. That's because the Earth is reacting to other magnets. And for example, this one here, this is Earth is a magnet, this is a magnet. Okay, and I'll show you closed field lines. An example, here we go. Now, as you can see, they start coming out here and pushing and start pushing back. That is Earth, the magnet. It's a working magnet. It's pushing those other magnets away. You can see that in a ferrocell on Scientific Lee's channel, or even on my channel. I have a video explaining why there are closed field lines. Okay, so this is just a pretty basic video to get people started. What we have here is Earth pushing. We have our stray magnetic field, the blue, and then we have polar cap lines in here connecting to this object and this magnet that's in here. We have multiple sources just in field lines. Then we have density showing. We have multiple indicators that, polar cap lines are coming in, circling, and then dropping out. So it's a very good indicator. There are planets and moons here. I didn't go over these IMF. These are signifying the connection between the sun and all the planets, the sun's magnetic field showing with Earth, because we are connected to the other planets through the sun, but not directly to us. So they're shown as IMF. These should be pretty straight up and down, and do move around some, but as you can see, there are situations now uh, they're just not there at all because of the interactions between all these magnets. This is right here. This is about a 25-minute data gap, what you're seeing here. This is induction heating. This is where Earth is getting the energy to have the energy for these closed field lines. Induction heating, which is causing a lot of effects on Earth that we were seeing, like earthquakes, increase in earthquakes, volcanic activity, landslides, due to the increase of earthquakes, wild weather, oceans warming, electricity through matter creates heat. You overload a extension cord with drawing energy, electricity through it. Your extension cord is going to get warm. Well, that's the same thing here on a planetary scale. And you can see some solar wind blowing through this as things, but it's all still, as you can see, Earth was just pushing and pushing constantly. This is in the 6-hour window. And other indications of, rocks in the stream, in a sense. There has to be something there to get these kind of effects. Magnetically, energetically, water flowing through your stream, wind blowing through skyscrapers. They designed that around the wind for the least resistance. So it's all the same concepts here in space. It's just energy. Okay, I guess if you guys have questions, post them in the comments, and then another time I do another tutorial video on iSWA, I'll try to cover those. Yes, you'll also see the solar wind tool and the magnetopause position on iSWA. Other tools are available, radiation belts, and little tools, though I don't really like this one. I'm about ready to change it, but it is interesting. I am watching these current sheaths. This pretty much used to always be straight. That's the way it's depicted, but now it's always S-shaped and curved, or going way around. This is Earth. Quite interesting little magnetic energy effects going on, considering it's a spiraling effect out from the sun. So, anyways, that's a little and then some there. Oh, and I'll just throw in too, planetary alignments do not happen in straight lines. Planetary alignments, actual planetary alignments where energy could be transferred from the sun to all the other planets, happen in curves. And as you can see here, the energy from the sun is curved, spinning out like a fan blade or a propeller. Well, here's Earth in the model, so let's just say this is Mars or whatever for the example, okay? And obviously Mars is inside, closer to the sun. This would be more of a planetary alignment connected to the sun. This is more correct than something over here. So I just want to throw that out there, that I think, that could be changed at this point. If you want to really think about planetary alignments, you need to think curved. All right. You guys enjoy your weekend, and I will as well. Laters.